IBM machines were called electronic calculators, and they were not programmed by storing instructions in a memory, but instead by manually plugging wires. An employee, Cuthbert Hurd, instead wanted to store the program in memory, as was done in the von Neumann architecture. And he convinced a new IBM president to make a commercial machine, which also could be programmed using punch cards in order to store them, the instructions in a memory. And this was the first team of programmers which was hired. So that was an interesting event, at least for us who are programmers. So these include John Backus, Fred Brooks. Fred Brooks has written a very readable book, The Mythical Man Month, which should be compulsory reading for everyone. Okay, I will not talk more about it, but put the link to it. And then John von Neumann was also hired as a consultant. And this started the really amazing story of IBM computers, which is quite long. They are still very strong. Okay, so the first commercial scientific computer was the IBM 701, and it was introduced in 1952. Okay, and it had, well, you can see the specification, but it had the 36-bit words, so it was not the common 32-bit word or something similar. And 2 registers were accessible to programmers. They sold 19 systems. Next, the IBM 704 was introduced 3 years later, and the chief architect was a then young person, Gene Amdahl, who had the Norwegian ancestry. As his PhD thesis in physics, he built a computer. So, and then he got job at IBM as a new chief architect. So that's quite an achievement. Okay, and this new machine was the first mass-produced machine. Not exactly in millions copies, but 123. Okay, more than double the number of accessible registers, and this is a very classic machine in that both Lisp and Fortran were created on this machine. Okay, one thing that we will note several times here is that software was incompatible with the previous version or the previous machine. That is something which we don't expect currently, except when Apple switches architecture from something to something else, as it is currently doing. So this is Gene Amdahl visiting Norway, and his wife, of course. Okay, now there was a researcher, John Koch, and another, Daniel Slotnick. They wrote a first memo on discussing parallel computing. And they proposed SIMD processing. What does that mean? It means single instruction, multiple data. They didn't use that word. It was coined later on. So what is SIMD? It means that there is one instruction which tells the machine to operate on several data items and doing the same operation, such as 4 add instructions or more. Okay, and this was an improvement to the previous machine, and again it was incompatible with the previous machine. Though this time they wrote an emulator which could run the previous machine's software. One difference or improvement is that previously it was the CPU which did the I/O, but now it was a separate smaller processor called an I/O channel which did this. Okay, and then 1790 it was introduced the following year, and it was similar but had transistors instead of vacuum tubes. Now we come to a very important thing, namely to avoid the annoyances of buying a new computer and having to buy new software or rewrite the software every time a new machine was bought. So the IBM 360, its importance cannot really be overestimated. It was introduced 1964, and the idea was that the same software, I mean, it was a family of machines with the same instruction set architecture, meaning that the more expensive and faster machines could run the same software. So a customer could start buying an inexpensive, well, very expensive, but anyway, machine, and then when they needed more compute power, they could upgrade to a faster machine and still use the same software. Okay, and what is fascinating is that this machine is, I mean, the architecture is still around. If we look at some data from the most recent version, it has a 10 cores from 2017, and it's quite high clock frequency, and it can have up to well, actually, at least that, because it's a previous version which could have up to 10 terabytes of RAM. And when I was searching for this, I couldn't find the maximum amount of memory for the most recent machine. But anyway, it's huge. And these machines are very actively used currently. Of course, they are extremely expensive, but they are used. So this IBM 360, it introduced many of the things which we now take for granted. The 8-bit byte and 32-bit words, and that we could address an individual byte and not only a word. Now the number of general purpose register had increased dramatically to 16. One thing that happened is that it had 24-bit addresses, which is of course very little, and that has certainly been extended to use the 10 terabyte. And another thing which was first for this machine was something called a translation look-aside buffer, which is it's a, well, okay, I must say something. When we have multiple programs in a machine, they use blocks of memory called pages. A page is typically 4 kilobytes. Okay, and if I mean, if we have many programs in the memory at the same time, all of them cannot have all the data in the physical memory. So instead, some of that is stored on secondary storage, such as a disk. Okay, and in order to determine where the memory is stored, we use something called a page table, and this table is a mapping from address to physical ROM. Okay, and to improve the speed of this mapping, there is a hardware cache called the TLB, or Translation Loci Buffer, which means that it is very efficient to have this so-called virtual memory. That is taken for granted in every new machine, but it was introduced with this machine. Okay. Another thing, the first data cache was also introduced with one version of this machine, the Model 85. Yet another thing was the Tomasulo's algorithm for out-of-order execution, which was introduced in a high-end version. Okay, and we will not go into the details, but it's a way to keep track of instructions so that they can execute in an order which is more efficient, but does not correspond to the order in which the program was written, but of course giving the same output. So with the IBM 360, there were so many important things that are taken for granted in modern machines. Okay, and then they tried to build a still faster machine, which was called the IBM Stretch. It was the fastest machine from 61 to 64, but the design goal was to be 100 times faster than the previous machine, and that failed. And okay, and it was not a commercial success either, but it introduced several important things, such as instruction pipelining, and the names of pipeline stages that we will use. I mean, it's used not in this course because we don't talk very much about it. Well, we will to some extent, but in, for instance, efficiency and in computer architecture at another department. I mean, at the EIT department. The names are used: fetch, decode, execute. They originate from this machine, and also memory interleaving, which makes it faster to access memory. Okay,